Hello, everyone, and welcome. As you're getting settled in here, my name is Julie Noblet. I'm the Community Manager for the Diagram Center, and I'm really delighted to welcome you to today's webinar, Accessible Math for eBooks using MathML Cloud. A quick word about the Diagram Center in case we're new to you. We're a nonprofit R&D center. We're funded by the U.S. Department of Education, and our parent organization is Benetech, a nonprofit social enterprise based in Silicon Valley. Along with our partners at NCAM at WGBH in Boston and the U.S. Fund for DAISY, we've been conducting R&D for the last 5 years to make it faster, easier, and cheaper to create and use accessible images.
Someone just said there's no audio on the chat.
Okay. Maybe we can ask our friends at ReadyTalk to check on that. Oh, no, everybody else can hear. Good. Okay. So I'm going to go ahead. As we get settled in, just some housekeeping. If you would like to download the slides, you can find them right now on the Diagram Center website at diagramcenter.org/webinars. If you need live captioning for this webinar, in addition to logging in where you are now, please also log in to the captioning window by clicking on the caption text link that was provided in your registration, which I have also provided in the chat window. So you'll be logging into two windows, one with slides and a second one with the live captions. Now, there are more than 200 registrants for our webinar today, so in order for everyone to have the best audio experience possible, you've all been placed on mute, so you can hear us, but we won't be able to hear you. But if you have questions as we go along, please type your question into the ReadyTalk chat window, which you should find in the lower left. And go ahead and practice saying hello right now if you want. Type a greeting into the chat and we'll see it. I can see there's already some chat here. We are going to collect your questions and answer them during the Q&A portion at the end of the webinar. And I see all those hellos. Hello. Our session today is 60 minutes. If you need to leave before the end, that is no problem. Our feelings will not be hurt. We understand. A recording of this webinar along with the PowerPoint slides are going to be available on the Diagram Webinars page in a couple of weeks, so you can come back and listen to it at your leisure or share it with colleagues. So as we're settling in, I'd like to start with just a word or two about the big picture and why we're here. I think we are all here because we know that math is one of the most challenging types of content for students with print disabilities to access and interact with in the digital environment. And historically, most publishers have rendered digital mathematical expressions as images so that those expressions display correctly. Unfortunately, math in digital textbooks is therefore often inaccessible to students with print disabilities. There is an important alternative to rendering math as an image, and it's called Mathematical Markup Language, or MathML. MathML is to mathematical content as HTML is to text. If all math were rendered using MathML, and if reading systems could support it, then math would be natively accessible in the digital environment. However, today, even when publishers supply MathML, few reading devices are able to read it, much less allow the student to navigate it. So to ensure that math is truly born accessible, there are two hurdles to clear. One, all digital content would be rendered using MathML whenever math was present. And two, screen readers, browsers, and other reading platforms would support MathML and display the associated information to all users in whatever format they need. So, and this is a chicken and egg problem. There's no reason for reading devices to support MathML if it isn't included in the source content, and there's no reason for publishers to include MathML in their files if the reading devices don't support it. So we were interested in how to break that impasse, and that's what the MathML Cloud tool is all about. Our speakers today are Sanders Kleinfeld, Director of Publishing Technology from OReilly Media, and Sue-Ann Ma, Product Manager at Benetech Labs. Sue-Ann is going to start us off by describing what MathML Cloud is and what it does, and then she'll pass the mic over to Sanders, who will tell us how and why he's integrated this tool into his production workflow at OReilly Media. And then, as I said, we'll leave 15 minutes or so at the end for Q&A. So with no further ado, let me turn it over to Sue-Ann.
Thanks, Julie. So for those who are just joining, on slide 5 is where I'm starting. And on this slide, what you will find is a quote from the National Governors Association. It says, STEM fields play an increasingly critical role in ensuring states' economic vitality and the economic growth of the nation as a whole. Every high school graduate needs essential competencies in STEM as preparation for post-secondary education, work, and citizenship. So really, our question when we started is, what happens when the STEM and the math equations are not available to a student or an individual? A few months ago, I was talking with one of the volunteers that worked on our MathML Cloud project. His name is Saqib, and he works for Microsoft over in the UK. And he happens to be blind, and even though he went through the best schooling systems with Schools for the Blind, with lots of resources and individuals helping him, he basically told me that around the age of 15 or so, or 10th grade, he essentially stopped learning math because it was too difficult for him to do so. Not because math itself as a concept was hard, but because he couldn't see the images that math are traditionally rendered as in books. He had to have somebody help him transcribe every single time he had to solve a problem in hand in homework. When his teacher needed to give him feedback, somebody would then have to read the equations out to him. And at a certain point, it was just too difficult and too cumbersome for him to even bother with. So even though he's this very successful engineer over at Microsoft, it's just incredible to imagine where he would have gone or might have gone if he had more access to a lot of the equations that are so critical in STEM. So when we started with MathML Cloud, we basically had individuals such as Saqib in mind. We wanted to help the underserved folks, such as those with print disabilities like blind and low vision, to gain access to digital math content. What we soon found is that as we promoted this project a little bit more and sharing it with the community, there was actually a lot of interest in math, even beyond the fields of print disabilities. All of the digital world, people wanted to know, how do you make math available? So if we think about our traditional classroom where math is solved with a pencil and paper, how do you show work with regards to canceling equations and giving feedback to students and handing in assignments and all these different ways of accessing and reading and interacting with math? So when we started with MathML Cloud, really our main objective was to start with reading math. So the initial goal was to make sure when a math is inputted in digital form, whether that's using ASCII Math, LaTeX, or MathML, those are some of the most common input modes, we wanted to make sure that a student or end user would be able to see the math rendered correctly, the way with all the proper symbols and exponents and all those different things that you can probably see on screen right now. And we also wanted to make sure that students were able to hear the math correctly as well. So in this particular case, it would be read as square root 54 and root equals x cubed. So all of these things we wanted to make sure were available. And so why was this such a big challenge? On the next screen, what you'll see is that there's lots of different components when it comes to digital math. There's several ways to input, whether, like I mentioned, there's ASCII, there's LaTeX, there's MathML, there's also various other ways, like what about dictation or handwriting or typing or virtual keyboards. There's lots of different ways to input. There's also lots of ways to output. So visual rendering, when you see the equation, there's different sizes, there's different fonts, there's different qualities, There's also the aspect of what you hear. The different pauses, different languages, different disciplines in math, whether you're using statistics or general algebra, the way that math is read is different. So there's a lot of complexity in the input and output, and then there's also all those additional needs that I had mentioned, such as solving math, collaborating, allowing students to be able to drill down and chunk into more digestible parts, as well as access math diagrams. There's a lot more things that we have yet to explore. But the challenge with all of this is that all the tools, whether it's reading, authoring, collaborating, it needs to be able to support math in the digital form throughout the entire process. And that's very difficult to do. So like Julie had mentioned, there's sort of this chicken and egg problem that we have started with, which is what happens with math in the reading with various reading devices. So we have a lot of math that's actually being created from what we went through this project from the initial source publishers, and lots of authors are actually creating it in accessible form. But because there's sort of this chicken and egg where a lot of the tools that needs to support math in a digital form throughout the pipeline cannot do so, it's lost. And centers will be talking a little bit more about this and what the workarounds are. But basically, what we were trying to do is figure out how to get around this problem. So in 2014, last year, Benetech received an award from Microsoft to work on this project. The first step, which is how to make sure people can read math. And what we did was we paired up with some of the powerhouses in the field. So we teamed up with the American Mathematical Society's Mathjax, which a lot of you are familiar with, I'm sure. And also we used Chromebox, so Google's text-to-speech engine, to produce a lot of equations, which I'll be showing you in a little bit. And basically what we wanted to do is create one tool and one solution that can work in the interim while there's sort of this chicken and egg situation, as well as promote the most accessible way to use math possible. So regardless of what state a reading tool would be in, or what tool, any authoring tool would be in, we would be able to maximize the accessibility and the availability of math. So I'm going to show you now what that looks like. In slide 9 and 10, there's actually, for those of you who perhaps would like to see later on what this looks like, as a screenshot, those are available, but I'm actually going to switch over to a live demo and show you how this works. So I hope everyone can see that I'm on the MathML Cloud homepage right now. This is essentially a demo tool for people to get familiar with MathML Cloud. And what I'm going to do is I'm going to input an equation using ASCII math. Like you can see that actually there's multiple ways to input math using ASCII, MathML, and LaTeX. But what's interesting is on the other end of what comes out from MathML Cloud. So I'm processing, and on the other end, what you'll notice is there's a few different components that comes out. So one thing is an auto-generated description of the equation that I just inputted. So here it says left parentheses upper A and upper B right parentheses equals P left parentheses upper A right parentheses P left parentheses upper A bar upper B right parentheses. So you can tell that it might not be the most depending on your audience, it might not be the best description. It's a little bit long and a little bit very not so natural in speech, but it is accurate. So the point of being able to auto-generate this is being able to be consistent in the way that descriptions are generated. So that's one output that comes out of MathML Cloud. And the benefit of having this description is when MathML, the math markup language that Julie spoke about earlier, is not supported by a website, a user or author or whoever it is can actually take this description and attach it to a couple different visual forms. One is the SVG, so it's a scalable vector graphics, and what that means is as you zoom in, for those with low vision, they're able to still retain the quality of the visual image. So I'm actually zooming in a little bit here, and you can start to notice how the SVG and the MathML is still retaining the quality, but for a PNG image, it actually starts to pixelate a little bit. So another advantage of this is we can also attach the description to PNGs or these basic images, which most tools will support. So that's basically how MathML Cloud works. I'm going to go back to the PowerPoint now. And again, if you feel like reviewing just the details of how this works, on slide 10 and slide 11, there is a screenshot. Sorry, that's a little too far. Slide 10 and 9 and 10 are where things are available. So thank you, Julie. And then basically on slide 11, MathML Cloud is available through integration in various formats. We wanted to make it flexible so that it could be plugged into various different types of production pipelines. So what I just showed you was the online version. It's a demo version that individuals can just try out. You can plug in an equation that you would like. Actually, in the screenshot, I used MathML rather than ASCII Math. And you can also sign up for an account, and that way you have a log of all the different equations and files that you may have uploaded to MathML Cloud. For our larger production houses, we've also provided 2 additional modes of integration. One is using an API. So what this means, and Sanders will be talking about this a little bit more, is that you can actually send equations through our API directly to MathML Cloud and get the outputted formats that you would like. So whether that means you only want the SVG in the descriptions, only the PNG in the descriptions, or you want the MathML, you can get whatever you want and you can plug it back into your production pipeline as you see fit. Another option is all of this project is open source. Benetech is a nonprofit, so this code is also available on GitHub. So on the MathML Cloud website, you can find out more information about this, but there's the open source code, so people can just feel free to take it and plug it into your own production pipelines, and that way you can alter the code, you can add features as you see fit. So again, the target audience that we really started off with MathML Cloud, we've received a lot of questions from various academic institutions and end users saying, hey, what about us? MathML Cloud we started as targeting more large production end users and partners, because what we were really going for was volume impact. We wanted to get out in front of the largest groups who were producing the majority of the content as soon as possible. So that was our strategy in terms of, okay, who do we reach out to first? We also realized that this tool is not something that's very easy for a lot of individuals to integrate. And so a lot of times, to really make it scalable and efficient, there are workarounds, and we've heard of them, but there are technical resources that are required to help integrate it into existing pipelines. So this is another reason why we reached out to more larger organizations. And also another reason that we really reached out to a lot of our publishers and conversion vendor partners was because we believe in born accessible. We want things to be adopted in an accessible format as early as possible in the production process. So we went to the source. Basically, we approached lots of various partners, and they kept pushing us up the pipeline, and ultimately we ended in the laps of the publishers and a lot of the conversion vendor houses. So, and also we wanted to reach out to a lot of Benetech's existing partners. We have relationships with publishers like OReilly, which you'll be hearing about next. So we wanted to leverage those existing relationships and really get things picked up very quickly. So I'll talk a little bit more at the end about where MathML Cloud's current state is and what we're looking to do next. But at this point, I'm really going to turn things over to Sanders, and so he can share at OReilly how they went forward with piloting and what they're doing with MathML Cloud and the impacts of this tool. So Sanders, please feel free.
Thanks very much, Sue-Ann. So my name is Sanders Kleinfeld. I'm Director of Publishing Technology at OReilly, And before I dive into talking about workflows, I just wanted to give a little background about OReilly and what we do and what our needs are around STEM publishing. So OReilly Media is traditionally a book publisher, but we also do many conferences. We produce magazines. We have all sorts of content online, and our mission statement is to spread the knowledge of innovators through all different types of media and get ideas out there. But in terms of our traditional business, we publish anywhere from 125 to 150 new frontlist titles a year. Most of them are on computing topics, on popular programming languages, system administration, things like that. And we publish all of our titles in both print form and also in the main ebook format. So EPUB for devices like iBooks and Nook, Mobi for Kindle, and PDF format for folks who are reading on their desktop computer or also on their tablets or smartphones. So, like I said, the majority of our frontlist titles are focused on computing topics, but over the years, increasing and now a small but still pretty significant percentage, around 10 to 15% of our titles, contain a significant number of complex mathematical equations. We publish a lot of titles in our big data space, and we publish a lot of titles that talk about algorithms and such, which lead themselves to equations. So there's a lot of statistics in many of our books. So we definitely have the challenge of integrating production of math equations into our workflows for both print and ebook output, and also to the web. So here at a glance are some bullet points about what our production workflow looks like. We've developed our own web-based platform for authoring content and producing content called Atlas. If anyone would like to check it out, there's a link right there. So it's atlas.oreilly.com. We do production on our books in a variety of semantic source formats. We use XHTML5 to produce many of our books. We've developed our own schema around that called HTML book. We have many authors who like to write in DocBook XML, which is a semantic XML vocabulary that's really geared towards technical book content, and many folks at OReilly were instrumental in getting that standard off the ground about 20 years ago. And we also have increasingly popular with a lot of our authors is a format called AsciiDoc, which is a lightweight, wiki-like markup language that's very similar to Markdown, which some of you may be familiar with, but has some additional semantics that are specific to long-form content like books. In terms of how we do equations, we like our authors to supply us with equations in one of two formats, which Sue-Ann both mentioned earlier when she was speaking. One is LaTeX, and one is MathML. Most of our authors prefer, when they're writing the equations out themselves, to use LaTeX just because it's a much more lightweight syntax. You're not dealing with a lot of angle brackets and a lot of tags to represent the content. So we get our equations from them embedded in the source in one of those two formats. And when we go to produce our print and ebook output, we have a workflow that has an automated tool chain that we use to produce them. So that's what I'm going to show on the next slide. So what you're seeing here at a fairly high level is what our production workflow looks like. At the top of this diagram, you'll see that as a source format, we either start with XHTML5 or we start with AsciiDoc or DocBook. If authors write in one of those two other formats, then we will auto-convert to XHTML5. So effectively, our canonical source format is HTML5. We also allow authors to write in Microsoft Word if they so desire, in which case, when the books come into production, we will convert them to HTML and do the remaining production in HTML. When time comes to produce our outputs, we use HTML as our single source to produce all of our different outputs. So what that means in terms of our own efficiency is that we only have one set of files to edit, whether we're producing a print book, a PDF, or an EPUB or a Mobi. And when we're producing a print book, we use a technology called CSS Page Media, which is a special CSS module devoted to basically making page output. So taking the same HTML and CSS that you would use on the web and breaking it up into pages and adding things like headers and footers. So we've written CSS style sheets for our print book, and then we use a proprietary tool called the Antenna House Formatter, which is the renderer that can produce PDF output from HTML and CSS. Another popular tool is called Print XML, and a lot of folks use that as well. And that's how we produce our print and our web outputs. In terms of, our print PDF and web PDF outputs. In terms of producing EPUB and MOBI, we've written some XSLT style sheets to take. We're starting with an XHTML5 single source format, and in that sense, that matches an output format of XHTML5 that's using EPUB. So there's not a far way to go, but we've written some automated XSLT tooling to produce the EPUB package documents, produce the table of contents, the manifest, and so on and so forth. And we combine that with special CSS to produce our EPUB output. Amazon's Kindle MOBI format is very similar to EPUB. It's really their proprietary version of EPUB. And for that, we have some additional XSLT we run to optimize our HTML content for Kindle. And then we run it through Kindle's proprietary tool called KindleGen to produce MOBI outputs. So all that's automated, and when we're ready to produce the various different outputs, we push a button or trigger a script in our system to produce those outputs. So that's all great. But as we started to do more and more math content, what we realized was OReilly's challenge was, how do we take our LaTeX equation source content and automatically convert it so that it's optimized for both the print and electronic output format? Because doing equations was becoming a barrier to the automation that we had put in place. And what we found, unfortunately, specifically when we were looking at the ebook space as opposed to on the web, where you can use the great library Mathjax to help render either MathML or LaTeX content, was that neither MathML nor SVG are currently viable equation formats for ebooks, just because there's very widely inconsistent rendering support across the e-reader ecosystem. So I'm going to show a few screenshots that illustrate this point, hopefully. So what I'm showing on this first screenshot here is an example of MathML that is rendering in Apple iBooks. Specifically, this is a screenshot from iPad. So you see here we've got some rather complex equations, and they're represented in presentation MathML, and they're rendering actually pretty fairly well. So iBooks does have fairly decent support for presentation MathML. It doesn't support 100% of what that spec puts forth, but it does represent enough to do some fairly complex equations, as you can see there. By contrast, what I'm showing in my second slide here is how MathML renders in Kindle Fire. Kindle Fire is the LCD tablet version of the Kindle. And what you see here in these screenshots of all these equations is that only the text from the equations is represented. None of the actual presentation of the content is being displayed. So the text is in position, things like fraction bars and square roots and sigmas, they're not rendering properly. So it's basically, from just a visual perspective, not particularly helpful to readers because they will not be able to understand these equations properly. So based on that, we felt that MathML was not really a viable rendering format for visual representation of content in ebooks at this time. So the next thing we looked at was SVG, because as Suzanne mentioned, it's a vector-based format, which is really great because equations will scale and not degrade in terms of pixelation at different sizes. And also, as Suzanne mentioned, there's the ability to embed accessibility text in it as well. So we looked at SVG rendered in iBooks, and again we found, as you see in this screenshot here, that equations rendered fairly well. Actually, MathML rendered a little bit better, but these are completely readable in SVG, and we thought perhaps this is a viable option. With some tweaking, we could embed SVG in our ebooks across the board. But again, we went and we looked at Kindle, and the screenshot you're seeing on the next screen is SVG rendered in Kindle Classic. So this is particularly a screenshot from the Kindle DX, which is the large format e-ink e-reader that Amazon put into the educational market several years ago. So some of the legacy Kindle devices, like the Kindle DX, the ones that I'm calling Classic here, as you can see in the screenshot, the SVG just does not display at all. You can't see it. So it's really important for us at O'Reilly because we want customers to be able to read our ebooks regardless of what e-reader they're using, that we produce ebooks that are optimized as best as possible for the wide diversity of e-reader ecosystem. And based on that, we had to rule out both MathML and SVG. And we also couldn't use a tool like Mathjax to improve rendering of things like MathML because most e-readers also do not support any sort of scripting around JavaScript, which made that also not viable. So what were we left with? What we found is that the only reliable universal ebook equation rendering format that we could use for visual representation of math equations was a bitmap format. So JPEG, PNG, GIF. So that raised a big question for us. How could we auto-generate these graphics from LaTeX and make them accessible? And that's where MathML Cloud came in. And that's where Sue-Ann and the work that the MathML Cloud team has done at Benetech has really, really come to the rescue and helped us out a lot. So what MathML Cloud offers, as Sue-Ann showed earlier, is a way to auto-generate those images from a LaTeX, a MathML, or an ASCII math source and produce alternative text using Google Chromebox as well. So even better, they had an API which we could use to add the necessary automation to keep our automated workflow running. So what I'm showing on this particular slide is a screenshot from the MathML Cloud API documentation on GitHub, which is really excellent. So what you're seeing in this particular screenshot is documentation of the API call you would make to convert MathML or LaTeX or ASCII math to an image. So for a closer look at that, on the next slide, I'm going to show you how you make a MathML Cloud API request. So what you see up top here is a sample LaTeX equation, the Pythagorean theorem, a squared plus b squared equals c squared. And below is a corresponding curl request that you could do if you just wanted to generate alternative text for that. So you're doing a post request, you're supplying the equation text, and then a few options saying that the source format is LaTeX, and that, yes, you want a description, and then you're posting that to the MathML Cloud API. And what you get back is a JSON, which is JavaScript object notation. It's a standard way of representing data that includes the alternative text description. So what we're able to do with that is our toolchain is built around a programming language called Python, which has libraries for doing things like making pull requests. We're able to basically add a few lines of code to our toolchain and say, take these LaTeX equations when you reach them, when you're processing the content for ebook output, and then make those requests to the MathML Cloud API, grab back the images and the alternative text descriptions that you're getting, and then insert that back into the ebook content. So the main benefit and a huge improvement that this made to our workflow over the way we were doing things before was that previously when we were doing books that had a lot of mathematical equations, we were having our illustration team produce those for us. So we would have someone take equation content that an author had either, mocked up in Microsoft Word using an equation editor or something like that, or perhaps they were providing us with LaTeX or MathML. And we would have an illustrator go into a tool like Adobe Photoshop or Adobe Illustrator and retypeset the equations meeting our particular conventions and standards, and then export out the graphics. And this was not a big deal if there were just a few equations in the book, but for books that had, 100 equations, 200 equations, this is extremely labor intensive. And worst of all, it was not amenable to doing things like revisions and updates, because if an author had to update an equation, we would have to get updated equation files from them. We need to go back to our illustration files, modify them, and re-export the PNGs or whatever we were using. So it became very labor intensive. So the main benefit of a MathML Cloud-based workflow is we can inject that LaTeX that the authors are providing us with. And we found our authors really enjoy providing content in LaTeX format. And we can, on the fly, auto-generate out those equations as graphics. And most importantly, we also have a mechanism for getting alternative text to ensure that they're accessible to people with visual disabilities or reading disabilities. And even better, because we're using LaTeX or MathML as a source, when we are exporting out to web formats, we can take advantage of tools like Mathjax and render that content directly in the browser right away. And for O'Reilly, just integrating MathML Cloud tools into our workflow is meaning that when we're doing math-intensive books, we can easily be saving 5 to 10 hours, maybe more, depending on the number of equations, in terms of our production staff and our illustration staff's ability to, or time invested to get the content out. Additionally, we also look at MathML Cloud as a way to future-proof our content, because we really, really hope that someday the vast majority of e-reader ecosystems will support math content represented in LaTeX or MathML or SVG. So we'll have that ready to go. We'll have our MathML at the ready at the time when that is supported. And hopefully that will mean a better experience for folks in the future, prepared for upfront by us. So that's sort of what we see as the main advantages. And I wanted to talk a little bit about what we've done thus far with our piloting. So far, MathML Cloud, we've been piloting for a few months now. And what we're currently piloting is the generation of PNG images from LaTeX source and generating all text descriptions using MathML Cloud. We recently released, our first ebook, our first EPUB for one of our math-intensive books that used MathML Cloud's API to generate the all-text descriptions. So I was really excited that, we've, now improved our accessibility for our ebooks. In terms of future work that we're looking forward to doing, we'd like to set up our own O'Reilly-hosted MathML Cloud server just so that we have our own cloud-based instance of MathML Cloud so that we can, store our equations there and have it put under our own network monitoring and things like that. So I'm going to be most likely working on that in the future. And we're also looking forward to finishing with the pilot phase and moving towards complete integration into the rest of our tool chain. And we're looking to do both of those things, by the end of this year, hopefully. So what I'd like to do now is I'd like to throw it back to Sue Ann to talk a little bit about what's coming next for MathML Cloud.
Thanks, Anders. So on slide, 26, basically the state of where MathML Cloud right now is we entered beta in May 2015, and what this means is we basically have about a handful of different pilot partners that we're actively getting feedback from, and we're just allowing them to have time, such as O'Reilly, to integrate into the process and give us additional feedback about features and different ways that we can tweak and refine MathML Cloud to make it better integrated into different production pipelines. So in addition to talking to publishers such as O'Reilly and a few others as well, we've also started talking a lot to conversion vendors as well as EdTech folks. So a lot of academics have actually been coming to us and asking about, well, how do we make our tools, how do we allow our professors and our instructors to also make math accessible from the beginning? So a lot of conversation has happened with various learning management systems and platform providers on how to best integrate MathML Cloud so that it can also be automated, and so students can then use whatever tool it is that they use to access this information and be able to actually interact with the math. So again, I mean, initially when we started, and even right now, MathML Cloud, I just want to reiterate, is not actually optimized for all individuals. So a lot of these academic institutions that are using MathML Cloud, we've heard, they've actually gone through a pretty manual process of inputting equations one at a time. And what we're really trying to do is, if there are needs to integrate with additional resources, contact us, and we're happy to also talk to various EdTech partners and figure out how we can kind of streamline and scale a lot of these processes. And then also, in terms of the feedback that we're collecting, we're also trying to figure out what do we do and where do we go next with MathML Cloud and math support in general. There's a lot of exploration and additional tools already happening. A lot of partners that are working with Benetech as well as just independently. A few folks that we've mentioned, you know, Mathjax, AMS is always trying to further this cause. There's also, we worked on recently, for example, figuring out as more and more math is made accessible at the born accessible basically in MathML format in the beginning, what, for example, tools can students and users use to read that? So I think we were primarily talking about books today, but what about the learning management systems? What about things that are in Word docs and PDFs? Like, how is support for that, both on the reading and the authoring side? So we're also trying to figure out how to create end-user tools to make those tools more discoverable and easier to use, because it is a very complex matrix of configurations and combinations that's needed sometimes to get that supported. And there's a lot of additional work, too, in terms of, for example, speaking math. We've worked with Steve Noble on a lot of this type of work, where today MathML Cloud is using MathSpeak as a default because it is open source and it's an open source rule set. How do we build additional rules for different countries and languages, or for different audiences, such as different grade levels or different disciplines in math? So there's a lot more exploration, a lot more work that needs to continue in the digital math realm. And this is sort of what we keep saying, this is just the first step, but we're excited about it. And if you have any suggestions and feedback on how we can continue to improve both the tool as well as just digital math support, feel free to contact us at any time. So with that, Julie, I guess we're going to progress.
Yes, so your questions have been rolling in via chat. Thank you so much for that. We are devoting the rest of the time to this Q&A, and I will read questions and ask Sue Ann and Sanders to answer as appropriate. And please know also that if we run out of time to answer all the questions, we will capture them and get answers in writing and put them up with the webinar PowerPoints and slides. So if we don't get to your question, don't despair. We will get you an answer. So there were a few questions, Sue Ann, that came in while you were describing what MathML Cloud is. And this is sort of a two-part question. Wondering why ebooks instead of just web pages? Is it different? And why Chromebox?
Okay. So with regards to ebooks and web pages, part of the reason was because there's multiple reasons, actually. It is slightly different. A lot of web pages, they do require sort of more Mathjax integration. A lot of the conversion happens in the browser. With EPUB, what we're also doing is making sure that first of all, there's different options, right? So with EPUB, maybe sometimes with various reading devices, PNG or SVG is the preferred mechanism, so it just provides a little bit more flexibility. And sorry, I can't, oh, it was removed. And then Also, with regards to Chromebox, it is also because that is an open source tool that we were able to leverage, and to really make MathML Cloud an open source, completely open source one, and make sure all the partners that we were working with were also in sort of the same mind frame, and we would be able to share the tool with various organizations.
That's great. Thanks, Sue Ann. And you might have answered this, but a question, does the description output follow the convention of MathSpeak?
Yes. So it is currently using MathSpeak. This, at the time of implementation, was the most well-known and open source rule set that we had, so we progressed with that. And like I had mentioned at the very end, is we are looking for additional ways to incorporate additional rule sets and building those and supporting those. So if, I would look to this in kind of the coming months and years in terms of additional rules that we would use.
Okay. Thank you. There was a comment, there appears to be inconsistent support for MathML in various browsers. And the question is, will use of the API serve as the workaround for this?
Yeah, so this is one of the reasons that we did produce MathML Cloud, because we know that not just browsers but also readers, there's just lots of varying support in terms of MathML. On certain web pages, it's not even just about the browser, it's also about the content source of certain pages too. So you might need specific settings. For example, Wikipedia, there's a way to turn on the MathML, but you would have to have to set up an account and actually turn on that setting. So what we were trying to do is, by making it available through an API, we're actually saying, well, first of all, not all of the content is web-based on browsers, but also giving people the flexibility to add content to the files at origin as well, so there's more flexibility there.
Okay, thank you. So there's a question here, is MathML Cloud like MathPad, that you can write and convert to MathML directly?
I'm not too familiar with MathPad, but MathML Cloud, and I'm not sure if this is specifically talking about handwriting or if it's typing, but MathML does have the ability to take, say, ASCII Math and Mathjax and convert it to MathML. So might need a little bit more information about that question.
A little more.
Yeah.
Here's another question. Is MathML inherently supported by EPUB 3, since MathML is recommended for HTML5 and HTML5 is an integral part of EPUB 3?
Yes. As far as I know, EPUB 3 does include MathML, so that is also why we went with MathML as the base, because of standards.
Okay. And
just really quickly. So yeah, MathML is supported as part of the EPUB 3 specification. The larger issue is whether e-readers support it as well. So there are still some e-readers out there that don't support EPUB 3, and even among some of the ones that do, there isn't support for MathML rendering. So I think everybody would love to center around MathML as being the display format within EPUB. The support just isn't there yet completely in the ecosystem.
Okay, thank you, Sanders. And Sanders, while we have you on the line, someone asked, what was the name of the tool that you mentioned that was alternative to Antenna House that can be used to convert HTML5 into printable PDF?
Sure, the tool is called Print. That's like the son of a king, Print. So I'm going to paste the URL in the chat for you all.
Okay.
Broadcast to all. There we go. So it's called Print XML. It's also a commercial tool. Right now, there aren't a lot of open source tools that can produce professional PDF from HTML and CSS. But there are a lot of open source development projects around that very task. So I hope that will be changing in the future.
Okay, thank you. So here's a question. well, I'll just read the question. Does this mean that the screen reader user who's reading these equations in an ebook needs to be connected to the internet?
The answer should be no, I would think. In the way we're doing it at O'Reilly is we're taking the alternative text descriptions and embedding them on the alt attribute on the IMG image tag. So the alternative descriptions are embedded locally with the content.
Okay. Another question, what is the pricing model and cost to the user for the O'Reilly toolset? Is that something you can share?
So right now the O'Reilly Atlas, it has a public beta if anyone wants to try it out, but we're still in beta right now. So if you have interest, please get in touch with us. I can't really give more details beyond that.
Okay, thank you. Here's a question. Someone's wondering about reverting from an image, a PNG, to MathML.
So I can take that one. There are certain tools that do OCR for math, so a lot of academic institutions are using something called Infty Reader, INFTY. What I have heard, though, is that it takes a lot of manual, basically validation to make sure that it is actually accurate. So in terms of doing that, it's a little bit troublesome. But also, for most cases that we're hearing, a lot of people are actually just going and retranscribing using something and then creating MathML that way. Sanders, did you have something you wanted to add?
No, we haven't had to do a whole lot of that to sort of reverse engineer those equations. So I actually don't have a whole lot of expertise in that area.
Okay.
Okay. Next question. What tools can we be using to give students access? Math players, screen readers?
So this is actually a great question. It depends on what is the format being read. And this is one of the things that I would kind of say stay tuned for in the fall. Benetech is working with a few partners to figure out basically end-user tools. So the idea is that an end-user could go to this web-based page and say, hey, I'm using, for example, NVDA and I have a Windows. What are the different and I need to read a web page, for example. What are the different combinations that are supported today, and what are perhaps the settings that I need? And we're trying to build on this database and say, okay, well, what if it's a Word document, or what if it's a PDF? What are the different combinations that are supported? And you might find sometimes you have to go to a Mac, or the only available resource is, iBooks or something like that. So we're working on building this tool, and I would say stay tuned for that in the fall, because it's very different. It's not a straight answer in terms of, it really depends on what tools that you're trying to use and what formats.
Thank you, Suran. And someone asks, are other publishers adopting this?
Yes, other publishers have adopted this. I don't know if one of them is here. Hawks Learning is another one. They're a small publisher, and they've adopted as well, more on in a manual basis as well. They're also looking to see if this is something that the API would be something that they could also leverage. In terms of other publishers and organizations that we've been talking to, unfortunately, I'm not allowed to disclose who they are, but there are a few, probably a handful or so of others that we're in active discussion with. Also a few conversion vendor houses as well. So, and I'm not sure if I'm allowed to reveal names, so I will err on the side of caution and not, but there are a couple of pretty large service providers that we've also spoken to that have integrated MathML Cloud into their production pipeline.
Okay, and that's sort of a follow-on question to that. Someone asked, can this be built into any LMS, learning management system?
I mean, a lot of times it definitely will require some tweaking to the LMS system. We've been talking to a few different organizations. Sometimes in many of these cases that we've spoken to, MathML is already supported, images are already supported, but the problem sometimes is, for example, well, actually, some of them MathML is not quite supported, but a lot of cases is actually with how do you provide access to when an image is provided. So we've definitely been working on integration processes where we're trying to help automate the process of adding the alt text so that at the time of somebody typing it in, that is created and that's available, because sometimes they're saying their students don't have a tool that can read MathML, even though a site might be able to support it even. So having alternative forms and resources is good to have. So again, it's kind of a case-by-case situation in terms of the best process forward. And there's also questions about, ASCII math and what happens if input is in one mode and they expect the same output, or they expect ASCII math is not very readable or something like that. So definitely reach out to us if there's specific platforms that you would like to see get MathML integrated, and we can figure out what makes the most sense.
Okay. If instructors have materials in Word, how can we assist them in converting documents to accessible materials? That might be a bigger question that we can answer offline, but I guess in particular, is there a role for MathML Cloud in that scenario?
Yeah, unfortunately not a very obvious one right now. I think we'll probably ask Neil to talk a little bit more about that. I think math type is the best solution, specifically if it is Word. I know learning management systems might be a little bit different because at the time of authoring there might be ways to integrate MathML Cloud, but if it's specifically Word, we have worked with Microsoft a little bit to try to see if there's ways to add plugins and add-ons so that the text is auto-generated as well, but that's not yet in place.
Okay. And are there sample files available for people to test out the reading of math within applications?
So that's interesting. We were actually on a call yesterday, and people also mentioned that the support matrix that we had mentioned is basically taking a few fundamental formats, so web pages and Word files, PDFs, and a few others, and testing out that capability and support. So actually, I think this is a great case that we should really add sample files to that tool. So I'll look into adding that when it becomes available.
Cool. Okay. How would MathML Cloud work with screen readers, such as JAWS 16 or Window Eyes?
So MathML Cloud, if you actually open it up, it depends. Again, I think that tool that we're building is going to be very useful, but MathML Cloud today, like if you were to use, I tried it a few times with JAWS and NVDA. It depends on the browser, again, because certain screen readers are only reading MathML in certain combinations. So, for example, if you have MathML with IE or Firefox, I believe now as well, or NVDA, with those two, it'd be supported. But if you were to use Chrome, it would be different. So a lot of times, it's not just about MathML and when it's available in the browser. It's also about the combination of tools that you're using, so that it actually is a very complicated combination sometimes that needs to be set up. But obviously, if you are using a screen reader and trying to access the text descriptions and so forth, that would be available when you're on MathML Cloud as well.
Okay, and we have time for just one more question. And as I said, we'll gather up the ones we didn't answer and get answers to you. So MathML Cloud uses content authored in LaTeX and renders based on MathSpeak rules. Is it a JavaScript library similar to Mathjax? Has your testing found you can get math to render well in PC versus Mac, mobile devices, e-readers?
So that might be one that I'm going to defer to a little bit later. But yeah.
Okay. Well, we will. That's a complex question that deserves more time than we can give it now.
Yes. Thank you.
All right, and let's wrap up with this last one. Sanders and Sue-Ann, how do we contact you? Is there a group, listserv, other email?
Yes, I think at the very beginning of the slide deck, is our information available there? I can't, maybe not. Julie, do you recommend usually?
Yes, you can always write to info@diagramcenter.org, and we will make sure that any messages get to Sanders or Sue-Ann. And there's also a contact us link on the MathML Cloud.org website. So you can poke around there, and if you have questions, just send them on. So this was a terrific, lively session. We've gone all the way to the beginning.
Sorry, I was looking for the email addresses were there.
Okay. So as I mentioned at the top of the hour, a recording of this session along with the PowerPoint slides will be posted to the Diagram website at diagramcenter.org/webinars. In a week or two. I'll send a note to you all when those are ready. And in the meantime, don't hesitate to email us, as I said. If you enjoyed this presentation, you may also be interested in the library of webinars like this available from the Diagram Center. They're always free for you to access and share with colleagues. The URL is there along with the titles of other resources we have. So with that, please join me in thanking our presenters today, and thank you for spending this hour with us, and we hope to see you next time.